Good afternoon and welcome to DOB's 2021 Digital Construction Safety Conference. I'm Matt Milner, Director of Engineering for Construction Safety, and I'll be discussing Outrigger Scaffold, thrust-out platforms, and supported scaffolds. Okay, as I said, today we're going to be discussing construction safety, Outrigger Scaffold, thrust-out platforms, and supported scaffolds. Now, construction safety is critical to a successful project. That's one of the main themes I want to get across today. External construction equipment, including supported scaffolds and outrigger thrust-out platforms, have been erected to facilitate the construction of buildings throughout New York City. When implemented properly, the equipment can be effectively used to complete projects. When improperly implemented, the safety of the workers and the public and property is compromised. As it relates to this topic, this course will review critical aspects of the New York City construction codes, engineering considerations, common deficiencies, and case studies. Some of our learning objectives today. We're going to review the code requirements for both items, supported scaffolds and outrigger thrust-out platforms. We're going to be looking at common errors and omissions that we've seen throughout all the phases of these projects, whether that's design, inspections, or the implementation and construction. And then finally, we're going to demonstrate the importance of this through case studies. So what are we talking about? Well, here's our first photo of the day, set to frame our conversation. At the front of the building, exposure 1, you see a supported scaffold. Related to this project, at exposure 2, you see an outrigger thrust-out platform above the neighboring building. Sitting on top of that, we have another supported scaffold. So these are critical elements as it relates to the safety of the public and adjoining property. We're going to start off with our building code, because that will help to define the safety items involved with these elements. Our scaffold provisions are found in Chapter 33, specifically Section 3314. Now, this scaffold section has multiple types of scaffold described, whether it's mobile scaffolds, suspended scaffolds, or supported. Today, we're going to focus on supported scaffolds, which means that they're scaffolds that are supported by outrigger beams, brackets, poles, legs, uprights, post frames, and prefabricated frames. There are 3 common categories for the loading of these elements. We have light duty, which has a load of up to 25 PSF, pounds per square foot. We have medium duty, which can withstand loads of up to 50 pounds per square foot. And finally, heavy duty, which is up to 75 pounds per square foot. Above that, you'd be into an extra heavy duty category with specific design accounting for the additional loads. Now, it's important to note, especially because we're discussing this today, you're not allowed to have a heavy duty supported scaffold if you're on an outrigger thrust out platform. The highest you can go is medium duty. When we want to quantify what medium duty means, this doesn't mean that you can place a pallet of materials on top of the scaffold planks. They can't support it. You'll get excessive deflections and potential failures of the materials. So what does 50 PSF mean? Let's visualize it. If you have a 1 foot by 1 foot square and you want to load that with 4-inch brick, 1 layer, you're almost at 50 PSF. So these elements require permits. I think it's safe to start by saying, assume you need a permit, and I've provided you with the exceptions to this. This is also in the code. You don't need to take my word for it. This is all published online, and it's available. So with supported scaffolds, you may be exempt from a permit if you meet all of the conditions that happen to be described, which would be if you're not an outrigger scaffold or thrust out platform scaffold. So that, plus you don't have hoisting equipment that is greater than 2,000 pounds, and your load is less than 75 PSF, and you have a height less than 40 feet. If you meet all of those criteria, you may be exempt from permit. The next logical thought is, let's discuss design. So for our particular element today, the Outrigger thrust out platform, design is always required, right? That's a specific code provision, 3314.3. The design provisions are not solely located in Chapter 33, and that's an important thing to realize. Where else can we find design? Well, we have the material chapters. We also have Chapter 16. 1604.2 defines what we need to design our elements to. And that's for the stresses, so we don't exceed the stresses of the material. 1604.3 discusses serviceability requirements. We don't want to have excessive deflections on our members, because that can also result in an unsafe condition. Our next natural transition here is to discuss supported scaffold drawing requirements. So we've gone over permits, we've gone over design. Well, let's look at drawings. This is actually one of the most robust drawing requirement sections in the code, which is great because it gives you specific direction on what we're looking for. 3314.3.3 discusses this in detail. We have structural members must be defined. The founding associated with the support needs to be defined. That can be many different elements, such as a sidewalk shed, floors, roofs, the ground, an outrigger platform. A plan view and an elevation view with full dimensioning and detailing must be provided. We have to locate all of these elements, connections and attachments to the structure, whatever they may be, anchorages, fastenings, tiebacks, must be shown. If your structure needs to have base modifications, the base building needs modifications to support these loads, whether it's the wind load imposed or the vertical load imposed or horizontal load imposed by the scaffold, that needs to be indicated on these drawings. The netting associated with this element needs to be identified with the manufacturer and type specified. Hoisting equipment, we discussed that may be a condition for permit. So the hoisting equipment and associated load rating for it must be identified on the drawings and located. Our platform levels are also important. Why is that? This is a significant weight element. So you don't want to have all the levels platformed, planked, and used at one time, depending on what your scaffold is and what it's designed for and what the founding is designed for. So you want to have the support centers, offsets, maximum numbers of levels loaded simultaneously, and maximum load imposed identified. But these aren't all of our drawing requirements. Similar to design, the code has additional information scattered. I'm going to try to organize it a bit. So 28104.7.1, we're going to start with our administrative code. That's what we're talking about. That gives us a definition that drawings need to be of sufficient clarity to show the full extent. Additionally, our admin code has provisions for special and progress inspections that need to be identified on the plans, material identification. Structural plans are a good section to look at because it has a detailed drawing section. These scaffolds are structures. They need to be detailed enough to be able to be built. And one thing we didn't talk about yet is the intent of our code is to establish reasonable minimum requirements. These aren't maximums. And actually, often we see that people exceed the minimums because they need to by design. Some examples of where we might have special and progress inspections called out for a scaffold would be post-installed anchors. These are elements that require a certain capacity to be tested. And how can an inspector test something if they don't know they have to and what they have to test it to? And if you have base building modifications, you may need to have additional inspections for that base building, such as structural steel or concrete or cold form steel. In terms of material identification, this is where you're really going to have to define all of the manufacturer or call outs or property specifications for the materials you're using, whether they be frames, side brackets, tiebacks. If you're using outrigger platforms, you likely have steel or planking, guardrails, anchors, and netting. So this is an overarching principle in the code, no matter what sort of drawings you're producing. Now we're going to transition to the safeguards. We're mandated to keep scaffolds and their supports in safe working order. We can't have any known problems, defects, hazardous conditions, or maintenance problems that could compromise the safety of the public and property. Our loads, now this should go without saying, we can't load an element in excess of what it's allowed to be loaded to. We can get failures. So it's clearly written out in the code, in the law. Our capacity for the scaffolds is defined. What factor of safety do we need to have? Well, these elements need to have the ability to support their own weight plus 4 times the maximum intended load. The code mandates that we keep these elements stable and secure. You don't want to have these elements lose balance, overturn, collapse, or fall, or have any object from the scaffold, the user on the scaffold, fall to the public. You'd be surprised how many complaints we get about falling material and equipment, and our next topic, dislodged scaffolds. So the materials, equipment need to be stored and braced to the point where you don't have a dislodgement case. And what may be a primary source of dislodgement? Wind. There's a specific cease use for supported scaffolds and scaffolds when you have sustained or gusts of winds that exceed 30 miles an hour. This is a big thing. So how is your site going to check for that wind load? What notifications are you going to sign up for to ensure that you're not working and operating under these sustained in gusts? There's another common sense principle here in terms of use during repair and maintenance and installation. Only people that are qualified or conducting the work are allowed to use it during that time. And generally, the code defines when the scaffolds are mandated to be non-combustible. That's when you have exterior scaffolds that exceed 75 feet in height, interior scaffolds that exceed 21 feet in height, and any alteration, repair, partial demo, and occupancy groups, I1 through I4. Associated with these dislodgements, let's define a critical principle in the stability of these structures. That's the height to base ratio. When we have a height to base ratio, so the base of our scaffold, the width versus the height, that's 4 to 1 or greater, they need to be restrained by elements preventing movement. So that may be tying, guying, bracing, or an equivalent means. And those are mandated to be installed at locations where horizontal members support both inner and outer legs. We want to have a load path. In terms of these guys, ties, braces, supports, they need to be installed pursuant to the manufacturer recommendations or designed. And at a minimum, the first guy, tie or brace, must be installed at a horizontal member not more than 4 times the least planned dimension. And that gets installed from the base and repeated vertically at intervals that are every 20 feet or less. Now keep in mind these are minimums for scaffolds that are 3 feet wide or less, and every 26 feet or less for scaffolds that are greater than 3 feet wide. Horizontally, these intervals cannot exceed 30 feet. Speaking of critical principles, I want to highlight Outrigger thrust out platforms, and the critical safety elements that we have specifically in the code. And why might we have something in the code? Maybe because there's been failures. So take that as a lesson learned. Now, here's where we get the specific reference as to the maximum loading for these elements, 50 PSF. Just this is all in 3314.14. And it further defines that both our inboard supports and our fulcrum point, so the point about which this is tipping, must be restrained against all movement and directions. That means vertical, horizontal, and rotational. We don't want to have a twist on the element causing a failure. We need to restrain it from lateral torsional buckling. Now, if we have post-installed anchors, this is where it specifically mandates pull-out tests for these elements. And what are we testing these to? A factor of safety of 4. In terms of the fulcrum point, this section further mandates that you have 6-inch minimum bearing in each direction. You can't have these elements tip at the fulcrum point or the inboard end. They need to be securely fastened. Makes sense, right? We don't want to have any adventures on our job sites. Loads imposed are important. Our load path is important. One of the first things they teach us as entry-level engineers is you trace your load path. The scaffold and associated equipment Outrigger platform imposes a load on a base building structure. In terms of loads imposed letters, it's specifically required that when you're on a temporary structure or supporting a scaffold on a temporary structure, there needs to be a signed and sealed letter certifying the acceptability of that equipment of the scaffold equipment on the temporary additional equipment. That's signed by and sealed by a registered design professional, and it must certify the adequacy of the sustained load. Now, it's important to note that there's an upcoming code proposal which will increase this loads imposed letter requirement to include the base building and roofs, if you have a scaffold on a roof, so any base building structure. And that would be a great thing to have. It's a critical thing to have. We don't want to have any ventures on our neighbors' properties or on our own property. And it makes sense because you have to check it anyway to have a sufficient design. Now, while it may not be an official law yet, the department can require more stringent requirements than what we have now. So if there's questionable construction or something that may be deemed essential for the safety of the health of the occupants or users of the structure or the public, on specific cases, we can require a loads imposed letter on the base building, and we might. So that's matters not provided for. The department has the power to safeguard the public. You should be doing this regardless. So we know loads are important. Support conditions are just as important. The code specifically references footings and anchorage. They must be rigid, sound, and capable of carrying the maximum load without having excessive settlement, movement, deformation, and it must be secured in every direction. We don't want to have any adventures, especially as we're using the equipment. In terms of scaffolds supported on structures, the code actually doesn't require a letter, but it says you must make sure that the structures that are supporting this equipment have not exceeded the allowable values for those structures. And you need to have distribution members, such as dunnage or shoring, to help make sure that you don't exceed these loads. So you already have the mandate. You may be requested to provide an additional letter certifying compliance. In terms of installation and removal, now we've framed a lot of our other thoughts, safeguards, permits, drawings, design. Let's talk about installation and removals. Supervision is required for this because it's a potentially unsafe operation. We want to make sure that it's safe. The supervisor is a competent person, and that competent person must meet the training requirements set forth in Chapter 33. Now, if your scaffold is 40 feet or more, thus needing a permit, these requirements are 32-hour training plus an 8-hour refresher every 4 years. If you have a worker that's simply relocating existing decking, planking, or guards to a different level pursuant to the engineer's drawings or the architect's drawings, they only need a 4-hour supported scaffold with a 4-hour refresher every 4 years. Now, in terms of inspections, we have our scaffold installed. We need to have a qualified person inspect these elements. So installation inspections first. And that person is qualified by both the designer and the installer, not one or the other, but both have to sign off on this person. They have to have the associated training and be accepted. Their job is to verify all components are safe and in compliance with the design drawings. You can't have use until this has been signed off. And again, with all of these inspection reports, they're not required if design is not required. In terms of pre-shift inspections, this is a competent person prior to each shift. These reports are signed and dated. You're verifying that the structure is in a safe condition. No use until it's complete. Now, the code currently does not specifically note this, but this is one of the clarifications that's being pushed forward or hopefully pushed forward as part of the legislation proposals currently underway. The training requirements for this person doing the pre-shift inspection would be a 4-hour supported scaffold with a 4-hour refresher every 4 years. In terms of inspections following a site repair or adjustment, that person needs to have a description of the results, be qualified, have a signed and dated report describing what was done, how it was repaired, and what the outcome was. No use until that report is done either. Now, just so you don't have to take my word for it, I've provided the code sections for you. We've gone through them. They're available for your future reference when this gets posted. So we're just going to skip past a few of these. I want to acknowledge that there is a history from the Board of Standards of Appeals for supported scaffolds. There's BSA meeting minutes 362, 44, SM that have some standard criteria for cookie cutter supported scaffolds. The second you have a registered design professional signing and sealing plans, this BSA is irrelevant, doesn't apply. I don't want to see notes on the drawings that say design this or build this pursuant to the BSA because you're specifying a design. Now let's talk about some common errors and omissions for supported scaffolds. This is one of the most critical sections I can go through. We've gone through the code now. We're going to start getting into the application of the code and why it's important. Now, plans may not be project specific. This is a big one, and it happens a lot. And the risk here primarily may be that you don't account for the building geometry. How can you build something without accounting for the structure that's in place? You don't get the setbacks, the existing cornices in place, and then you have field modifications that cause potential dangers to the workers and the public. It's unnecessary. Beyond that, as we started getting into, it may not be coordinated with the shed that supports it, the building that supports it, or the Outrigger platform that supports it. We have seen anchorage to compromised walls. If you're trying to support a scaffold with a compromised wall that you're repairing, that doesn't make much sense. You already have a structurally compromised condition and you're making it worse, and you're actually increasing the hazard. In terms of anchorage, we also see testing not done without having post-installed anchor inspections identified, the load requirements to test to identified, and this is a problem. We then have a questionable constructed scaffold. We have netting and enclosures not identified and erected. For our permit holder, I don't want to leave you out of lessons learned here. We see work contrary to approved plans. We see greater number of working platforms than what's allowed. And these are design items because it relates to our load path and the founding and the excessive deformation. We see missing diagonals, cross bracing, and tiebacks, all critical safety items. Guardrails, debris netting not installed or maintained, working platforms not fully planked, planks not tied down, subject to dislodgement. Material false statements on inspection reports. Now we have common errors and omissions in terms of inspection reports. The department relies on these accurate certifications for safety, and it's really not great. It's actually very bad when we have false statements in these items because it creates secondary safety issues. We see failure to notify registered design professionals and permit holders of nonconformances, and no inspections conducted. With that said, let's go into some field deviations that we see from time to time and define the code layout that will frame our thought on it. We see cut frames, whether it's horizontal or vertical, and horizontally cut frames certainly will reduce the capacity of the elements and be a significant safety issue. Vertically cut frames are likely because you didn't survey the sidewalk and the existing setup and the building itself, and they're preventable. They can be adjusted and have grillage and dunnage that will help spread out these elements and you won't have to cut members. But let's define what the code says. Manufacturer specifications must be followed. Safety measures and standards. We have people engaged in these operations must safeguard the public and property and institute all safety measures. Manufacturer specifications and equipment must be maintained safe. Beyond that, unsafe equipment must be taken out of service and removed from the site. We have our capacity of members defined as a factor of safety of 4. So all of the components. So if you have something that you've altered, how can you demonstrate that you have a factor of safety of 4? It's going to be an uphill battle to try to get this accomplished. You don't want to be in that position. In the unfortunate event that this has occurred and is found in place, then I would suggest having something like the following prepared. We need to have site-specific details of all modifications that were made, with a manufacturer letter that indicates that they've been reviewed and accepted for the field conditions. It's unlikely that you'll get this. A manufacturer protocol for accepting the means of cutting these frames. How are they cut? Were they torch cut, which may diminish the capacity of the material? Were they saw cut? Testing data for the cut frames, which includes any sort of eccentricity and moment that would be induced from members connected to it. Your side brackets, for example. And then that manufacturer needs to have a New York State registered design professional provide the recommendations in a signed and sealed letter, and it has to be accepted by the applicant of record. And then finally, as we described, we need to have a factor of safety of 4 for all the components, and it has to be clearly demonstrated and indicated. So you're going to have to develop a strategy for doing that. It's a hard thing to do, something that we don't want to see, and it's not required if you have proper planning. In most cases, we see that equipment get taken out of service and removed. I think this is a good opportunity to get to our first case study for supported scaffolds. And dislodgement and anchorage is a pertinent item to start with because it's one of the items we see happen the most often. This particular incident happened during a wind event that was within the last year. We can see 2 main things happened. The actual frame itself cracked under the wind loading and dislodged. Makes us question the anchorage and the existing design. And the planks weren't secured. Our planked levels created a secondary hazard. They got caught up in the netting and are hanging above a public right-of-way. So this is very hazardous, especially during these wind events, because the wind doesn't stop when we want it to. It continues. And it might take a long time to secure this, and the public's exposure to this danger is increased. So with that said, it turned out that it was a design problem in terms of the frame itself. The dislodgement of the boards was a builder problem where they weren't secured to the scaffold system. That should never happen. So we have a deficient wind design, Chapter 33 actually references back to Chapter 16, which tells you have to follow the wind loads for Chapter 16 for the design of scaffolds. You're not exempt from wind loads. We had to take some immediate actions. Those actions included street closures and emergency work to secure the scaffold and the associated components. But as you can imagine, this emergency work was not an easy task. We don't want to have a situation where we have to put personnel in danger or increased risk because we haven't done the right job to start with. After this incident, everything gets secured. The owner decided to replace the applicant. It's their discretion. They decided to replace the applicant and get somebody that would do the right job. That scaffold is redesigned to account for the wind forces that this area was exposed to. And it wound up being that additional tiebacks were included, and especially at the corner locations to account for the corner forces. Beyond that, this applicant decided that it was prudent to do a wind action plan to provide an additional factor of safety. Not that his base design wasn't for the wind forces as it was. However, they wanted to make sure that there were additional measures in place in the event that there were high wind loads. That included netting removal, planking removal, and local dismantling where required. I don't see how that's personally feasible, especially in a wind event that goes across the city. It would be very difficult to do all of those actions, especially with staffing capabilities, and you can't be too many places at once. So a wind action plan is not something that I think is feasible. But in this case, they proposed that as well. Our next study is related to the bracing and anchorage of these supported scaffolds. This is an example drawing of a supported scaffold attachment. And with that, you can see the anchor location. You can see the spacing of said attachments and anchors, which appear to be generally in compliance with the code. And the balance of information was on other drawings. One big thing we want to point to is that the brick wall itself was identified. Here's an elevation of the scaffold and a section through it. If we look at what actually was out there, we look at what was actually out there, and we can use some of our existing lines on this slide now. We see fold form steel framing. It wasn't brick masonry. So we have a different material type on site. That's problematic. So we have work that was performed contrary to the drawings. We have an installation inspection and pre-shift inspection that were falsified. Now again, the department relies on the accuracy of these certifications by a competent person that has the training to be truthful. If it's not truthful, you're not doing anyone a service. There could be a secondary incident and hazard. And I can tell you that this attachment requires a design. It's critical that this has a design. This cold form steel framing does not have residual capacity in many cases. It's designed to be very efficient, and you're trying to save material when you use an optimized system like that. You might need additional reinforcement and base building modifications, like the code mentions, to have something like this. Now let's get into some Outrigger thrust out platform, common errors and omissions. And I want to preface this whole section by saying that the coordination and location of these elements is critical, whether you're doing an alteration, a new building, or a demolition site. And you might have some different considerations in each case. For example, at the demolition site, if you're removing floors or sections of floors or whole floors, that might impact your support and your restraint conditions, and the sequence needs to be coordinated. This is a thing that you would want to coordinate on your drawings because you're looking at the loads imposed on the structure. When you're altering an existing building, perhaps you're creating new openings. Perhaps you're changing that base building or adding additional columns. That's why this needs to be coordinated in advance. You can't have your outrigger and support locations conflict with the proposed information. So beyond that big picture framing for this, we see wrong code sections cited. I saw one this morning, actually. We still see 2008 code references and prior, which is a little crazy since we've had a new code since 2014. We see the scaffolding for these platforms that get supported on these platforms not shown on the drawings. We need to see those related applications so we understand and the contractor understands what's going to get built. The inspection requirements for post-installed anchors and other materials are often missed and not identified. That's a crucial thing, so these can't get inspected if that's not identified. Additionally, we have seen design failures where the beams don't work for analysis. That's both junior beams and the outrigger beams. That's a very significant issue. We've seen no restraint at the fulcrum. That's a significant hazard. We've seen inadequate inboard restraint or supports varying locations that don't match the plan or that don't match and get coordinated with the field conditions. Failure to specify connections, missing dimensions, and loads called out greater than medium duty, which is not permitted. For permit holders, we see work without a permit, work contrary to the permit, varying support conditions, for example. No installation inspection reports getting coordinated before use or removal, or changing the scaffold with winds that are greater than 30 miles an hour, and stockpiling materials, dropping pallets off on the planking, not allowed. In terms of our inspection errors, it's pretty similar to what we saw for supported scaffolds, where we see tons of material false statements. You have an incident on your site, I guarantee you the first thing the department asks for is your installation, pre-shift, and maintenance inspection reports. This is not something you want to falsify. This is the line of defense here in these systems. Failure to notify the permit holder and design professional of any deviation from what was mandated in the design and permitted by the department, and no inspections conducted at all. Now let's think about some remedial actions that might be required if we have an incident. In terms of the department's involvement, if you have an incident on your site, I can assure you that there's going to be follow-up inspections. It may get sent to engineering technical review, which will be with my team. That's not a place you want to be. You could have cease use of the equipment and exterior work. This will create delays to your project, change orders, whole mess. You don't want that, besides the public safety hazard. You might have emergency work that requires stabilization or removal, monitoring. We might mandate an inspection program until this is brought into compliance. And that may mean frequent structural stability inspections after wind events or during this removal or securement. And the department may need to create a safety zone because of the overhead hazards through vacate orders. It's not something we want to do, something we're forced to do. Now let's think about the secondary hazards that we may have to deal with if we have an incident. We have to secure or brace something. What's the wind load during this? Are we able to successfully accomplish it during this wind event? Is the existing work in conformance to start with? Or are there secondary hazards that we need to identify and mitigate along with the primary hazard we've identified? This is a real risk, I assure you that, and that's come up many times. Now, generally, these platforms will have a supported scaffold on top of them. What's the interaction with the supported scaffold? And is that supported scaffold tied to the base structure? Because that may be inadvertently creating additional restraint of some fashion. Will the removal of any of those tiebacks be problematic going forward? Then finally, are the components of the platform securely fastened, or do we have another tipping dislodgement hazard on our hands? our final segment will be getting to some case studies for these platforms. I think it's worth taking a look at our first photo again, the subject of our presentation. We can see our supported scaffold at the front. At exposure 2, the left side, we see an Outrigger platform with a supported scaffold on top. And I'm just going to highlight an initial thing we can see from the street. Our Outrigger beams, I'll try to draw them because it's a bit hard to see. I think there might be one here. They don't go full length. That's a problem. We have a deck that's cantilevering out with a guardrail system, or in this case, a parapet that's acting as a guardrail system next to it. So we know that we have a hazard to start with, but we have a scaffold in place that has tiebacks in place. So we have a deck that's not in conformance and Outrigger beams that aren't full length and not in conformance. We know that off the bat just from the outside. This is before our incident takes place. So let's see what happens next. Next, we're going to see what the drawings called for, because this will help frame our case study. So our drawings start by calling for inboard supports. We can see that. I'll draw a little arrow here. So the inboard end has some supports, and it has some rotational support shown with a related detail somewhere else on the drawings. Defines a concrete slab. We're going to see how accurate that is. We see a brick wall called out. So at least graphically depicted here, called out elsewhere on the plans. So the base building has a brick wall, according to this. We see an 8-foot length projecting from the face of the wall, 12-foot length inboard. We have the cantilever outrigger beams identified, W8 by 15s every 8 feet on center with a 20-foot main beam. Well, 12 plus 8 is 20 feet, so it doesn't look like the designer has accounted for our wall thickness. That might be a problem for us here. Calls out junior beams at 2 feet on center, and it shows no deck cantilever. So we don't have a cantilever space out here because our beams are supporting it. All right, so now we've defined what was intended to be built, although we have some errors. Let's see what happened. During this incident, we had an overloading of materials. They were actually removing parts of the scaffold and stockpiling them on the edge of this cantilever system with a cantilever deck that was non-compliant. And they were patching the exterior wall as they were going. During this patching operation, they disconnected the tiebacks. These tiebacks were providing additional restraint for the scaffold, and in some ways restraining the fulcrum point to an extent of the outrigger platform. Upon this removal, during a windy day with winds that may have been projected to exceed 30 miles an hour, there were reports of this scaffold walking out. So as the wind was blowing, this scaffold was walking. It's walking towards the edge of the platform, and eventually the platform hit a critical buckling moment, had a lateral torsional buckling failure of the beams, and a collapse of these materials due to this overloading and improper build of the equipment and improper falsification of the installation. Worker injuries occurred. An emergency operation occurred to help rescue the workers, putting public safety personnel in harm's way. Remember, we don't live in a bubble. Our operations impact other people and the city. With that said, we have overhead hazards for the neighboring properties. This is a problem. And we might have a remnant hazard still at the rear. So we have to vacate this building, and we're going to vacate parts of the adjoining building to create a safety zone. This is the roof of the adjoining building where all the materials collapsed on. A total failure of the roof joists. Full vacate orders required. we're standing in the rear yard of the adjoining property here. We have remnant overhead hazards, and we can also see we have the same problem with the outrigger system further back in the building. The beams don't project far enough out. The deck is cantilevering, and it may be hard to see, but you can see a visible deformation of the edge of the deck as it's loaded here. So the removal of that scaffold on it may be problematic because right now it's tenuously stable until such time we start to touch it again. So we have a partial vacate of the rear yard and the extension of the neighboring building, 2 doors down. Now I mentioned the fulcrum point, the existing structure, and lateral torsional buckling. This is an example, if I've ever seen one, of lateral torsional buckling where we have the steel beams warping from the loading. We don't have any restraint. There's nothing securing the fulcrum point from movement in all directions or torsion. Additionally, I don't see brick. This isn't a brick wall here. You can see cold form exterior stud wall and a steel building. So we don't see brick. So this was never designed properly for the application. And if you're going to be bearing this on cold form steel framing at any location, this opening that we're looking at here on the left side was also not on the plans or part of the design. So it wasn't coordinated with the building. But if you're going to have this bearing on cold form steel in any location, a distribution track is likely. You need to have a distribution member because the tracks for the cold form steel are not designed to be in bending like that. And those individual studs certainly will not be able to take that force. You may need to double up, have built up members to receive this loading. So let's take a look back at where we started, at our drawings. As we had just reviewed a bit, we see there's that brick wall. So we have an incorrect identification of not just the wall material, but the base building structure itself. We didn't have a concrete structure. We had a steel structure with concrete infill through metal deck on concrete. And we don't see any restraint to this fulcrum point. Even if this is built into brick, it's unlikely it's going to be fully grouted or restrained adequately. So this is a design consideration that was not accounted for. Just to wrap up what we've discussed, we have inaccurate, incorrect lengths of beams. Maybe they were installed 20 feet and didn't account for this exterior wall composition. So you have a couple foot gap at the end. We have a cantilever that was never on the drawings. Work wasn't stopped by their affirmations of the safety. And we also found that the inboard support locations varied. The spacing of these beams varied as well. We had removal of scaffold tiebacks and use of this equipment on days that exceeded 30 miles an hour or potentially exceeded. In terms of the inspections, same old story here. We have material false statements throughout. There was actually a repair that took place with another falsification with the intent for the department to rely on its affirmation. So let's think about some of the lessons learned here. In terms of design, we know that sufficiently sized structural members are critical, along with the fulcrum and inboard supports. We need to make sure that these supports have adequate restraint in all directions, including vertically, horizontally, and rotationally. An accurate understanding of what the base building is crucial, and you're likely going to be asked for an installation inspection report or a load imposed report that affirms that you've checked the base building. From our inspection point of view, let's have some discussion. It's prudent to verify the exterior conditions from the street and then verify the interior conditions. Make sure everything's in conformance because you might not be able to check the outboard length unless you're at the street level. Utilize checklists to affirm code compliance. and notify all parties when there are non-conformances. In terms of the permit holder, we can understand that the fulcrum and inboard supports are critical. Locating these things at the spots where the applicant has placed them is critical, and if they deviate, you need to notify them prior to installation. This is coordinated in advance. The installation links are critical. You must correct hazardous conditions. You can't have a non-conformance go uncorrected. That's part of one of the fundamental laws associated with the equipment. Overhead hazards will endanger the public and your workers. A cease use is not optional when you have winds exceeding 30 miles an hour. You need to make sure you plan and secure the equipment prior to that. And your construction sequencing is important. Make sure that you coordinate this with the applicant of record prior to removal of scaffold tiebacks. Our final case study is a similar topic, and it's going to involve a bracket-supported scaffold. Not quite an Outrigger platform, but similar enough that I wanted to spend a few minutes talking about it here. This is a case study from a little bit ago. It took a long time to resolve this stop, to bring this into compliance, and you're going to see why in just a little bit. We're going to focus on this location of the supported scaffold. It's above an adjoining building, and you'll see that we actually have a bracket platform. So let's zoom in a bit. It's a bit tough to see what we're looking at. I wanted to show this photo to give you an overall sense of the magnitude. Our second close-up here is showing a supported scaffold on this bracket with some outrigger beams. Those beams have supports above and below. The supports look questionable to me. I don't think you need to be an engineer either to see that these supports may be a bit questionable. And it looks like we're tying into some sort of steel structure. This is in use. So this has a heavy amount of load on it. There are a lot of planked levels. This is not a lightweight structure. So the design is critical for this, and installation is critical. So what did our design show? Here's the plan view showing the location of this equipment. It specified 160-foot tall scaffold on beam. They don't have the locations of these brackets specifically called out, but they do have this detailed D identified. Let's see what that detail shows. The answer is not much. The detail calls out a beam size for the horizontal member without specifying a spacing. That's incredibly deficient. They call out additional supports with no specification of size or spacing, and no connection to the base building or horizontal member. And finally, the horizontal member does not have an attachment to the base building identified, or even an indication of what that base building is composed of. An incredibly deficient design, and it's shocking that this passed an installation inspection report that was certified with the intent for the department to rely on it. And it's really a shame that a contractor thought this was okay to build this. And for ownership, this was a huge problem to resolve. Again, this is what it looked like on site. Removing all this equipment, it's a big operation, has secondary hazards, additional reinforcement may be required prior to that operation. You don't want your project in this situation. So to summarize some of the results here, it had a long storied history, but it resulted in the removal of the non-compliant scaffold, a long-term stop work order. There were engineering technical reviews of this and all the other exposures, and all the parties involved got oath summonses. The permit holder, applicant of record, so on and so forth.